All right, number 4. This was common on both the AB and BC exam, and I thought one of the parts was interesting, and I'll explain why and how I think some people can get confused. Okay, so here's number 4. The continuous function f is defined on the closed interval x is between -6 and 12. The graph of f consisting of two semicircles and one line segment is shown in the figure. So right here, okay? Let g be the function defined by g of x is integral from 6 to x f of t dt. Find g prime of 8, give a reason for your answer. So we need to differentiate this. That's just fundamental theorem of calculus. G prime of x is f of x. As simple as that. So g prime of 8 is f of 8. All right. So let's go to the graph. What's f of 8? That's 1. So g prime of 8 is 1. This one was easy, hopefully. All right, part B, this is the one that can get tricky. Find all values of x in the open interval, -6 to 12, at which the graph of g has a point of inflection. Give a reason for your answer. So conceptually, it's easy to understand that the points of inflection of g occur when g double prime changes sign. Okay? Remember doing the second derivative test and all that? Okay, so we need the second derivative of g. So we already found in part A that g prime of x is f of x, right? Right here. Okay, so we need g double prime. So g double prime is f prime. Whoops, wrong screen over here. Okay, so we want when, as I said, when g double prime changes sign, which means we want when f prime changes sign. Okay, and then f prime changes sign when f changes from increasing to decreasing or vice versa. Okay? Here you have to be careful. It is true that f changes from increasing to decreasing when f has that's a relative max, right? And f changes from decreasing to increasing when there's a relative min. Okay, so that would cover this and this. So we know that the easy 2 points are that points of inflection occur at x is -3 and x is 3. Okay, but what about this point over here? Here's the confusing part. Okay, so let me go through it and explain. I was looking at other instructors' solutions and they didn't give a good explanation why. So hopefully, if you're really wanting to understand why we should include x is equal to 6 in our answer, hopefully I can explain it, okay? The confusing part is f is not differentiable at x is equal to 6. Okay, there's a sharp turn here, corner here. Okay, derivative from the left, the slopes from the left are negative, the slopes from the right are positive, so derivative doesn't exist. Okay. However, f, if we just look here, it does change from decreasing to increasing. Even though it's not differentiable, does that mean that there's a point of inflection for g here? It does, because I'll show actually a graph of g in a bit, okay? G is continuous at x is equal to 6, okay? Because g of 6 is integral from 6 to 6 f of t dt. That's 0. So g of 6 is 0, okay? So g is continuous at x is equal to 6, okay? So because it's continuous and it's continuous before and after 6, right? Right before and right after 6, okay? We can always find a value for g. There's a concavity, actually. There's a shape for g, okay? We have to understand that, first of all. Even though f is not differentiable there, g still has a concavity, okay? It's just not a point of inflection, or sorry, it is a point of inflection. It's not changing sign there, okay? Is how should I say this better? Maybe my explanation is, let me just think out loud. Okay, so the key point is, first of all, g is continuous at x is equal to 6. As I was saying, the integral exists, right? G of 6 is 0. And right before and right after 6, g has a value there, okay? So g has a certain shape. It's continuous there. So shape, concavity, whatever, okay? Even though f has a sharp turn here, it's not differentiable there, g is still continuous, okay? That's the key point. Okay, so f prime won't have a value there, meaning g double prime won't have a value at x equal to 6. Okay, remember, it can still change concavity at times when, remember, or should I say, when we do the first or second derivative test, we also include points that are undefined as a critical points, if you remember. So that's what I'm trying to explain, okay? All right, so hopefully we recall that, and let's actually look at the graph of G. So I asked AI to plot it. I had to prompt it a lot, actually, to get it to look somewhat correct. I believe it's now correct. So let's look at the graph of G, actually. Okay, actually, let's go to part C first, and then we'll use our answer for part C to verify this graph, actually, okay? So we'll come back. So part C, find g of 12, so integral from 6 to 12, f of t dt. So we just want the area under this triangle because integral is area under the curve. So what's the formula for the area of triangle? Half the base times the height. So the base is length 6, the height is length 3, so it's 9, okay? G of 0 is the integral from 6 to 0, okay? So we just need to find the area of this semicircle, which we know the area of a circle is pi squared, so we have that. And then we add a negative sign because integral from 6 to 0 is the same thing as negative integral from 0 to 6, properties of integrals, okay? And if you do the math, the answer is minus 9 over 2 pi, okay? So the reason I wanted to do this first is because let's take note that g of 12 is 9, okay? And g of 0 is this value, okay? So g of 12 is 9 right there, okay? G of 0 is minus 9 over 2 times pi. That looks somewhat correct, okay? And then we know that g of minus 6 is 0 because we add this area and add this area, they would cancel out, so the integral is 0, okay? So g of minus 6 is 0 over there, okay? So this pretty much looks like the graph of g, I believe, okay? And we can even see that this should be positive area after 6, right? Which it is. It's negative area because we're moving backwards, and then it should be getting less negative because we're adding some opposing area. So this looks right, at least from a quick glance, okay? And this is just, if it's not 100% right, I apologize. But just to explain that, look, at x is equal to 6, G does change concavity, right? From right here, it's concave down. G, as I said in the key point, was it's continuous. At x is equal to 6, it's 0 as we expected. And then look, it changes to concave up. So it does change concavity at x equal to 6. So here's the actual graph to convince you, okay? And now hopefully you kind of understand what's going on and why we need to include x equal to 6. It is a point of inflection. It changes concavity. G changes concavity there, okay? Even though f prime was not differentiable, g double prime is not differentiable at that point, okay? Okay. Now let's go to part D. Find the value of x at which g attains an absolute min on a closed interval minus 6 to 12. Justify answer. So we need to do the first derivative test, okay? So g prime, which is f of x, we said earlier, about the fundamental theorem of calculus, we set it equal to 0 to find our critical points. The critical points are when this guy is 0, so minus 6, 0, and 6, okay? We know that since we're interested in absolute min, we only really care about the relative min, okay? We know that relative min occur when f, the derivative of g, changes from negative to positive. When does that happen? At x is equal to 0 only, okay? However, we need to check the endpoints as well. So we need to check still x minus 6, and we need to check x is 12. So we need g of minus 6, g of 0, because we eliminated we only kept 0 from up here, but we need to include minus 6 as the endpoint. And then g of 12, that's the other endpoint. Evaluate, we can easily find this. I already calculated it when I was explaining part B, but it's 0, this integral, okay? Because again, this area over here would cancel this area over here. G of 0 we found in part C. G of 12 we also found in part C. What's the smallest value? Right here, right? So that absolute min occurs at x is equal to 0. Okay, that's it. Hopefully my explanation for part B was helpful if you really wanted to understand why we need to include x is equal to 6. Again, from my quick glance of a few instructors who solved it, they didn't give a good explanation in my opinion, because even I myself had to think of why would they include x equals 6? And then after I thought through it a minute or two, then it made sense to me. Otherwise, yeah, as I was saying, other teachers didn't really explain it or at all, or they explained it not that great. So hopefully this visualization, can't talk, helped to understand and clearly convince you why. Okay. Please give this video a like if it has helped you or you found it interesting, and hopefully I'll see you in another video as well. Bye.